What's up everyone? So today we're going to solve a circuit using a nodal analysis. So this is our diagram, our circuit diagram, and our task is to find the V1, V2, and V3 by nodal analysis. So first thing we have to do is to find the dependent sources and its value, because in this diagram, as you can see, there are two dependent sources, and that dependent sources are in this sign, or in this left side. As you can see, this are this dependent source, which is called the current controlled current source, and this one would be the current controlled voltage source. So in theory, dependent source is a voltage source or a current source whose value depends on a voltage or current elsewhere in the network. So as you can see, these two dependent sources are depending on this given voltage source. So here we go. This is our solution. First thing, we have to find the value of the IO, or the uh, dependent source. As you can see, this is current controlled. As you can see, the sign is I, which means current. So first, we have to look at again in the diagram. The IO is given here, so which means in the node V3 and V2, uh, the IO exists. So therefore, the V2 minus V3 is equal to IO, which means the resistance there is 50. So again, we put it here. IO is equal to V2 minus V3 over 50, because according to Ohm's law, I is equal to VR. This is our I, this is our V, and this is our R. So V2 minus V3 over 50. So we put 2 here in the given diagram. There is 2. So we put 2 here, and we multiply 2V2 minus 2V3. So it is equal to 2V2 minus 2V3. And then you can also divide it already. Divide it easily, uh, so that you can get the IO as fast as you can. So 2 divided by 50 is equal to 25. So it will be cancelled, the 2 here. So it stated that the IO in the current controlled current source is V2 minus V3 over 25. So again, let's move up in this dependent source in the 5IO. So again, the same formula. The 5, put it 5 here, times V2 minus V3 over 50, which will be 5 minus 50 over 1 over 10. So 1 over 10 times V2 minus V3, which would be IO is equal to V2 minus V3 over 10. So again, let's use the KCL method for finding the node voltages. Uh, First thing we have to do is we go in the node 1 or the V1. So as you can see here, node 1 V1. As you can see here, this is the current control current source, 2IO. We already know that value, so it travels here and here from negative sign. So negative V2 minus V3 over 25 plus, as you can see here, 100s. This is the V1, so travel here from 0, V1 minus 0 over 100. So we just put V1 over 100. I'm sorry, this is V1, not VI. I will just paste it and put it V1. Okay, so back to work. So again, V1 minus V2 is equal over 25. it's just a simple pattern. You need to use the KCL method and the Ohm's law, which is the V over R, which is I. So again, we need to come up a little bit uh, space on this equation. So we need to multiply 100 because this is our LCD. I mean, yeah, LCD. So times 100. So multiply by 100 each term. So we come up that negative V2 plus 4V3 plus V1 plus 4V1 minus 4V. So the final answer for node 1 is negative V2 minus uh, 4V2. I will just put it V2 here. I'm sorry, I forgot to put V2 here. We'll just put V2 here on this side. The set of the equation. V2. Oh, right. So we need to arrange this. V1 plus 4V1 is equal to 5V1 minus negative 4V2 minus 4V2 negative 8V2 plus bring down 4V3 is equal to 0. That's our equation 1 for our node 1. So we come up here in node 2. Again, the same formula, right, using KCL method. So again, V2 minus V1 is equal to 25. I mean over 25 plus V2, which is here, minus 0 over 200. So we just put a V2 over 200 plus the V2 minus V3, which is 50, is equal to 0. So we need to use again, find the LCD so that the function will be minimized. So 200, come up with 200 by each term. So again, the came up that 8V2 minus 8V1 plus 4V2 minus 4V3 is equal to 0. So combine like terms, 8V2 plus 4V2, so you can see here, is equal to, I mean 8V2 plus 4V2 is equal to 11V2. Sorry, I forgot to put some V2 in here. So again, combine like terms, 8V2 plus uh, V2, which have this one is 1 value, so plus 4V is equal to 13V2. Again, bring down negative 8V1 because it has no like terms in this term here, and you also, as well as the negative 4V3 is equal to 0. And then last for the node 3, because we already have 3 nodes given here. So again, same method for using TCL, V2 minus V1 over 25. I know. V3 minus V2 over 50. So you can see V3 minus, again the same process, as well as this V3. 1 V2 minus 0.1 V3 over 5 plus V3 minus 38.5 over 20. So again, the LCD is 100. So multiply 100 to each term. So we come up that 2V3 minus 2V2 plus 20V3 minus 2V2 plus 2V3 plus 5V3 is equal to 192.5. Again, if you wonder that how 0.1 V2 and 0.1 V3 come up here, As you can see, as we recall, the IO for the 5 IO is equal to V2 minus V3 over 10. So we come up that the 10 should be so that it can be minimized, we have to put the 1 over 10, which is zero point 0.1 here, distributed to each term V2 minus V3. So let's continue. So the answer is, we have to again combine like terms. So negative V2, because negative plus negative 2 plus negative 2 is equal to negative 4, plus 28 V3, because 2 plus 20 is equal to 22, plus 20 plus 2 is equal to 24, 24 plus 5, eh no, 22, 24, wait, again I kind of made mistake here, so I'm sorry. I kind of mistake here. It's not 28, it's 29 V3. Bring down 102.5. So again, so that we can have a faster way in solving for the V1, V2, and V3, we have to use the matrix method in the calculator. As you can see, the technology today is more growing and so accurate to use. So as you can see, we have to put or use the calculator for finding the matrix. So first, in the first row, in the upper column, we have to put the negative plus 5, negative 8, plus 4 in here. So as you can see, plus 5, negative 8, 4, 0, V1. And again, next is the for node 2, negative 8, 13, negative 4, 0. And for the last is 0 for V1, negative 4 for V2, 29 for V3, and the 182 for its okay, for the value of this V3, V2, V1, we come up that the A1 minus B is equal to X. So the answer of this AX, we have to put some degree of negative 1 in here, times the B. This is the B. This is our A1, this is our B. Okay, right? Okay, you get it? This is our AX and this is our B. So if the AX, put it some degree in here, negative 1 multiplied by this is equal to X, we come up that V1 is equal to negative 50, V2 is equal to negative 30, V3 minus is equal to 2.5. So again, I will use some calculator for you to understand further. So again, okay. So again, let's continue. Uh, First thing, you need to put your calculator into mode, and then the matrix calculation, and use the edit here, mat A, 3 by 3 columns. So as you can see here, input this equation 5, so to 5, 5, oh no, 5 equals, so next put the negative 8 and 4, negative 8 equals 4 equals, next negative 8, 13, and negative 4, negative 8, 13, negative 4. Next is 0, negative 4, and 29. 0, negative 4, and 29 equals. So again, let's recheck. if the given equation I input is correct. So, oh no, right. Okay, so this is our mat A for the matrix A. Well, we can also clear that. It's no worry. Again, we have to use the matrix in chef mode. Chef plus matrix here. So you can see, edit some mat B in here, but we have to change the dimension in this column only. Okay, done. So we have to input what's the value, 00 and 192.5. 0, 0, 192.5. Okay, or 385.2. So again, we have to come back for the mat AX in here, mat A. According to my solution a while ago, as you can see, A to the power of negative 1 times B is equal to X. So I have to put some negative 1 in here. So the answer is here, times B times B shape matrix again. For the names is B. So as you can see, the answer is 50, negative 50, negative 35 over 2. Okay, so that's how I'm going to use the matrix calculation again. So thank you for watching. Thank you, Ma'am Dina. Thank you. God bless.